Donatas Abraitis, who is R&D engineer at Hostinger and software engineer at NetDev. And his presentation title sounds like that: FRRouting, BGP features you haven't used or heard. Please warmly welcome.
Okay, hello everyone. I'm Donatas from Lithuania. At the moment working as system engineer at Hostinger, software engineer at NetDev / open source routing, one of the co-founders of BalticNOG, and currently still an active FRR maintainer / developer since 2019. I was thinking what to talk about and decided people might be interested to hear something not very popular, random features pulled recently into FRR, some BGP capabilities and IETF draft. There are 3 hot prefixes at the moment: 0/8/127/824/4. There are sort of special ranges, and while IPv4 is still in demand, there are proposals to shrink these spaces and release millions of IPv4 addresses. From 0/8, there is a proposal to leave only a single address, which is 0000, and others should be treated as valid IPv4 unicast addresses. 127/8 is going to be shrunk to 127.0.0/16 and to 40/4 as it is. So roughly around 300 million new IPv4 addresses. If I recall correctly, Red Hat, to be more specific, MetalB, asked some time ago on how to peer an FRR using exactly 127/8 subnet. At that time, it looked a bit useless, but now I find it very useful, especially when testing interoperability issues between different vendors. Something like running multiple vendors on the same box. And in FRR, it's disabled by default, but there is a command to allow reserved ranges. And yeah, 240/4, by the way, is already used by some companies internally, including huge cloud providers. And one fun fact is that at least I know one company which is using IBM's ranges internally. Traditional BGP requires to specify whether the peer is internal or external by using fixed AS numbers. And AS numbers are exchanged in BGP open messages directly inside the packet in open message header, or encoded inside the capability if it's a 4 bytes ASN. And in FRR, there is a way to say whether the peer is internal or external without using AS numbers. And since 10.2, there is a way to say just auto. That reduces configuration overheads, makes more flexible, and especially useful in environments where AS numbers can change, like migrations or merges, some AS automation, of course. Combined with a numbered peering, that's beautiful. And the main problem with the numbered or interface-based peering is that once you have multiple vendors, most likely you will experience interoperability issues. And one of these is when the router sends 32 bytes next hops. And the real issue is when the receiver tries to handle global unicast address, which is actually link local address, or global unicast address is empty. And with this new capability, we send only a single next hop, which is link local address. Good news is that this draft is already adopted by ITF IDR working group. So hopefully get some progression. To be honest, this is one of my favorite things that's going to happen in BGP, hopefully. BGP capabilities are advertised in open messages. So in order to modify some capability parameters, you have to drop the session, which may damage other services relying on top of BGP. And this capability would facilitate non-disruptive capability changes. And it's actually a new message type, number 6. And it's used to dynamically send or withdraw the capability dynamically instead of relying on open messages. Unfortunately, it's not very popular among the vendors because it's not yet a standard. But it's enabled in FRRouting since 10.1, but only for data center profile. Normally, BGP doesn't use IGP metric for best path selection and relies on S path length. And using IGP, each link has a metric, and the path between the nodes has a distance, which is actually just a sum of the metrics of all the links that belong to the path. And this is a new optional non-transitive BGP path attribute, which is used to carry accumulated distance between the nodes. And when the node receives a route with this attribute attached, it can enable best path selection based on the AGP metric instead of using S path length. And the lowest wins. It's disabled by default, of course, and it's not possible to send this attribute between the external peers because it's non-transitive. So, but in FRRouting, there are a couple ways to do that. One would be using set metric AGP that technically converts AGP metric value to med attribute, which is transitive between external peers. Or another way would be using OAD peering. What is OAD, or what one is administrative domain peering? Some networks span more than one autonomous system and require more flexible way to propagate path attributes. It's worth saying that these multi-S networks belong to a common administrative domain, and RFC 7938 perfectly defines how eBGP is used at large scale. And yeah, these large-scale networks require to have an ability to carry any BGP path attributes between external peers that belong to the same domain. This is a new draft that technically defines a new peering type, which is called eBGP OID. And actually, it's nothing else than a regular eBGP, except that treating BGP non-transitive path attributes more or less the same as for iBGP. On previous slide, I talked that it's not possible to carry AIGP metric, and using this peering type, we can send AGP metric between external peers or sending local preference as well. BGP at path capability allows the advertisement of multiple paths per prefix without replacing any previous ones. And a large number of prefixes may be received by a router, potentially depleting memory, CPU resources, or even causing network-wide instabilities. For example, in FRR, one path is roughly 250 bytes, so with only mandatory attributes. So if we have a full feed, let's say it's 1 million routes, it's 250 megabytes. So imagine if we have 100 paths per prefix, so that would be 20 gigs or something. This capability allows indicating the maximum number of paths per prefix the receiver is capable / wants to receive. The at-path capability itself has a flag to disable receiving additional paths. Something like, I'm not interested in additional paths, don't send me any. While with this capability, we can ask, send me only 5, 4, or any number of best paths. In modern data center environments, we tend to have conventional routers participating in the routing process. And the fleet of routers has different versions of routing daemons. So it could be a crucial factor by knowing the exact version to quickly identify the root cause. And it especially could be useful today where AI is involved. For example, we can give a PCAP file, and AI could give us a quick summary analysis of what's going on, depending on the features or bugs for that version. Someone calls this like a Twitter over BGP or something, but it's already implemented for a decent number of open source and even not open source implementations, and tools like WarkShark. And it's enabled by default since 10.1, I guess, as well. Normally, BGP must send a notification message and drop the session to handle error conditions. And graceful restart mechanism requires that normal BGP procedures to be followed when a notification is sent or received. And this capability allows graceful restart procedures to be applied when the notification is sent or received, or even when the whole time expires. That means that when the two routers exchange this capability and have notification bit set for this capability, these routers can retain each other's route. This functionality actually can be defeated by sending a hard reset notification. It's a new type of notification message. Others are referred as graceful reset, and hard reset is just another type of message that encapsulates the original message. So once the receiver gets a notification, a hard reset notification, it decapsulates the notification to find the actual / original message, which is encapsulated as an inner message. In FRR, there is another useful configuration knob called hard administrative reset. And it's something like once you clear the session manually, like clear BGP something, the routers retain the routes until the session is reestablished again. When the route is propagated beyond the immediate peer, it's useful to allow certain characteristic to be forwarded further. And this is a new, quite fresh ITF draft called BGP next hop dependent characteristics. One of these characteristics currently implemented in FRR is BGP next hop nodes, which is already 10.4 release and more to come in 10.5. For example, in this diagram, R2 and R6 can send next BGP identifiers to R1, like in this example on the left. And for now, it's only for visibility purposes, but it might be possible to do something like a weighted ECMP or something based on the number of next hop nodes. Something similar to link bandwidth extend community does, but with more visibility and fine-grained control. Actually, a better example would be using close topology, where every path has an equal distance. So using next hop and next hop pair, we could avoid sending the traffic over the congested links or reducing the ratio for these congested links. And yeah, that's it from my side. I was quick.
Thank you, Donatas. It was nice hearing from you. So we have some time left for a Q&A session. Maybe we have some questions. Just raise your hand. Okay. Yeah. Sorry, could we just hear with the microphone? Okay, thank you very much.
So you're advertising new features. Any of those are used in production networks as far as you're aware?
Sorry, what was the question?
Any of those new features are already used in production networks, if you know it, of course.
Yeah, even not open source. I mean, in huge providers. I can't disclose this, but yes.
Thanks.
Mm-hmm. Okay, do we have some? Oh, okay, I can see.
A question about Grace for a start. Can you expand more? Why is it needed in FRR as a pure software implementation? My understanding is that GR is for those big modular routers. When the supervisor restarts and the light cards keep forwarding, but it's a feature that confuses a lot of people. and causes a lot of bugs in
Yes.
vendor implementations. Why FRR even needs this at all?
Yeah, because the vendors require it. So
Quick answers as well. Thank you. Maybe you have, any thoughts, any questions? We have some time left, so you can just, if you have any thought, okay, it will be more braver maybe during the coffee break
Yes,
or maybe
sure.
lunch break. Thank you, Donatas, once again.